start again.
And the problem is power quality improvement in the ACE building and wind tunnel system.
Yes.
So the power factor is really below, which is too much low as supposed to be as 0.90, which is according to the requirement of this. But due to low power factor, we have too much reactive power, which is wastage of a lot of power and consuming not like real power. So the university cost too much. They cost too much on reactive power, right?
Yeah.
So that's why we need a solution to improve the power factor and remove the harmonics. That's our objective, to improve in wind tunnel at ACE building, Automotive Center of
Yeah, you
Excellence.
said a lot of reactive power is wasted.
Yeah, so when we improve the power factor, that reactive power goes to a real work, right?
Yes.
So that's our basically problem. So we are designing a capacitor bank in order to do that.
And how did you try to solve it? Like, what process did you implement?
All right. So my partner can explain that.
Very well. I'm sure that he presented the problem of reactive power,
Yes,
etc.
being wasted.
Yeah, exactly. Because of the low power, let's call it low efficiency of the wind tunnel, a lot of energy is being wasted in the form of reactive power.
Yeah.
Very well. The capacitor bank here basically provides the reactive power necessary to bring the efficiency of the system back up. So you're no longer wasting power. That brings the operational cost of the building down. From our calculations, the operational cost of the building right now is over $10,000 per month, strictly operational cost. And after calculations, we realized that with capacitor compensation, the operational cost can be reduced down to $2,000. That's over $8,000 worth of savings, strictly in operational cost with our system.
So the process also included doing some monitoring of the system itself, and then using single line diagrams that we obtained, we were attempting to build a model of the wind tunnel system that we were working with at the ACE building, and then apply our design alternative.
Can you demo like how the software, how the simulations worked?
Well, the thing is that we didn't have access to enough information to fully simulate the wind tunnel system.
Yeah.
So this is not actually a simulation of the system that we were trying to solve. This is just proving that our filter
Proof of concept.
is able to filter out unwanted harmonics.
Okay.
Very well. The concept here is looking at these three rows. The first row is basically your perfect system.
Yeah.
That's the most flawless as you can get.
This is what you wanted
You
to
wanted
get
to.
closest to.
The second row is a distorted system, basically where we have problems in our wind tunnel system. I'm trying to simulate that with a distorted waveform. And over here is after our solution.
So what we've done is we're showing each of these systems on one row. So on the last one, we have applied our design alternative, and we're trying to see how harmonics have been filtered out from when they've been introduced to the end result. And we're trying to get this as close as this result as possible.
So basically, when you see it, this waveform is as close as to the perfect waveform as you
Yes.
can get. That's the whole idea of the system.
I get it. Okay. And what, like, in the future, what more do you want to, like, if you had time to improve certain areas of the project you've worked on now, what would those be?
If we had time,
Yeah.
the most ideal way is to properly simulate the wind tunnel system. Because this, as close as it gets, is not a wind tunnel simulation.
So we need access to more information in order to do this.
Okay.
So because we weren't given access, it made it impossible to simulate
Yeah.
the system itself.
Yeah,
So
that
due
was
to
the
lot
biggest
of
concern.
lack of information, we are unable to complete the full simulation.
Sure.
Yep, that was our.
But this is an awesome simulation because if you have a theory and a proof of concept, like you
It
get
can be done. It can be
Yes.
done if we can get the simulation right. If the simulation is right, this project could be completed. Thank you.
awesome project. Thank you. I'll take one of the first
Yeah,
ones.
sure.